The MP3 player. A high-tech hot rod capable of converting a warehouse full of music CDs into a lightning-fast stream of ones and zeros with a touch of a finger. A revolutionary device that has changed where, how, and when we listen to music. But how does it work? The engine that runs this super-powered miniature jukebox is such a marvel of technological design, we'll have to break into it to believe it. A printed circuit board is the MP3's command center, taking requests to turn power on and off and processing data as the spinning wheel selects a song. The flash memory cards store information as electricity. They retain information even when not powered, so if the main battery dies and the backup battery goes too, the music is safe. The LCD screen is a miracle of optics. The screen's layers recreate pixel by pixel a multitude of moving images. Each pixel is made up of 3 subpixels, red, green and blue. These primary colours can combine to create any colour. But the subpixels need light to do their job. Behind the screen, 3 diodes generate that light, which is reflected by the casing and made uniform by a filter before it hits the screen. Each subpixel is controlled by electrodes. By controlling the electric current flowing in the electrodes, we can control which liquid crystals stay opaque and which ones allow light to pass through. The pattern of red, green and blue subpixels creates an image on the screen. Every MP3 player needs a pair of headphones. Using a magnet and a copper coil fixed to a membrane, the headphones transform electric signals into sound waves. These high-tech components are impressive, but what's even more impressive is seeing how they work together to become an MP3 player. There are 3 electrical circuits under the wheel. It's the wheel's job to connect certain circuits with each other. Current from the printed circuit travels through a wheel connector and then continues out into one of the 3 circuits. The incoming current is analysed by an integrated circuit. The system is designed so that as the wheel turns, there's always a connector on circuit 1, another on circuit 2 or 3, and one circuit is not in contact with a connector. It's not always the same connectors making contact with the same circuits, but there is always a connection between 1 and 2 or 1 and 3, and those connections alternate as the wheel turns. The connection may be 1 and 2, then 1 and 3, with the pattern repeating, 1 and 2, then 1 and 3. If the sequence is 1, 2, 1, 3, 1, 2, 1, 3, the integrated circuit scrolls the screen one way. If the sequence is 1, 3, 1, 2, 1, 3, 1, 2, the screen scrolls the other way. If the wheel is turned quickly, the sequence is quicker, and so is the scrolling. These black boxes in the printed circuit are microprocessors. They contain thousands of electric microcircuits. The information travelling in those circuits is a series of zeros and ones, called bits. For example, pressing on the control panel to choose a particular song produces a stream of ones and zeros. The sequence enters the microprocessor, where it's analysed and processed. Then, other sequences exit, perhaps as instructions to retrieve the song information from the flash memory, while another sequence makes a confirmation message appear on the screen. And the music plays on. The MP3 player jam-packs music and technology. It's an electronic optic acoustic miracle that frees up music to go anywhere.